Good afternoon, trig and precalc fans. I'll try this a second time here. There was some definite brightness problems that we were having with the notes from before, so I'll try it again. I reduced the brightness. I think the shirt is causing something. I don't know what it is. I'm not the tech person here, so I'm going to try it again. Hopefully this will help you out a little bit. Every year or every day you come into this class, you walk past the board right there and you see what looks like a spider's web on the backboard. Okay, today what we're going to talk about is we're going to talk about the polar coordinate system and what that is utilized for. When dealing with, and if I want to shoot my spidey webs, I could do that. When dealing with curvatures of graphs, sometimes it's a little bit easier to deal with things in polar coordinates rather than in rectangular coordinates, which is XY coordinates. So what we have is a polar coordinate system here. And what we'll go through is we'll go through graphing on the polar coordinate system, and then your homework today for what I posted is a worksheet. You'll be able to do the front side of the worksheet today. But if we take a look at the polar coordinate, this point right here is called the pole. That is the pole. Okay, it's like the North Pole. If you look at a globe and you cut off at the equator and you look at the North Pole, or look at if you flatten out the map, what you see is you see lines coming down, you see circles that go around. That's basically what this is called, polar coordinates, because of the North Pole. And you have the lines of latitude and longitude that go down and circle around the Earth and the globe. That's what we're looking at here. Now we have lines that go all the way around, and this is an east reference type of graph. So this line here is 0 degrees, 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210 degrees, 240 degrees, 270 degrees, 300 degrees, 330 degrees. Okay, so this is your angles of rotation. You have also circles here that are units that are away from the pole. How far are you away from the pole? Now you can count these circles, these units, as anything that you want. You can count them by 2s, by 4s, by 10s, by 20s. You can go 1, 2, 3, 4, 5, 6, or you can go 1 here, 2 here, 3 here, or 10, 20, 30, 40. You can count them out as many as you wish. What I'm going to do for us today is I'm just going to look at this, is that 2 circles out is going to be 1 unit away. 2 circles out would be 2 units away. And 3 circles out would be, or 6 circles out would be 3 units away. So this would be a half a unit here. This would be 1 1/2, 2, 2 1/2, 3. Okay, so hopefully we want to be able to space these out so we can be able to get our graphs on here. But once again, if you wanted to, you can count out this is 1 unit, 2 units, 3 units, 4 units, 5, and 6. That's up to you. It depends on what you're trying to graph, really. Well, we have 2 variables here. We have a theta variable, which is your angle of rotation. What is your angle of rotation? I'm trying to stay off to the side here so I don't have the glare and you can see it a little bit better. We have the angle of rotation here. And then we have the r variable, which is the distance that you have away from the pole. What is my distance away from the pole? Okay, and you count them out by the circles. What's my distance going out? And this will create an ordered pair of r theta, where my r, my distance, goes out from my pole, and theta is my angle of rotation. I get an ordered pair, just like xy ordered pair, we get r theta ordered pair. So if we plot some points here, here's a point, 2 and 30. So my r value is 2 and my theta value is 30. Now you can do this either way. I can go out 2 units, 1 unit, 2 units, and then rotate up 30 degrees. That would be one way of doing it. Or you could say I'm going to rotate 30 degrees and count out 2 units on my circles. It's up to you. Whatever works. It's like if I'm using x, y coordinates, I could go out x and up y, or I could go up y first and then over x. Does not matter. You get the same point. So if we plot the second point, 3, 120, I'm going to rotate 120 degrees and then count out 3 units on my 120 line. So it's 1, 2, and 3. So there would be my ordered pair of 3 and 120. What I want you to do is go ahead and plot the next one. 1, 2, 10. Go ahead and plot it. So I go out my 210 line and I'm going to go 1 unit. So there would be my ordered pair 1, 2, 10. It looks like it's going to be better for you. I can see that it's not as glaring on what we have here. So hopefully the notes will be a little bit better for you. I'm trying. So if we take a look at the last one, the last ordered pair is -3, 300. So if I go out my 300 line, I rotate all the way around to my 300 line. This tells me I have to go out 1, 2, 3 units. If I would go to there, that would be the ordered pair 3, 300. Well, we don't want to count, we don't want to plot the point 3, 300. We want -3, 300. So if I go out 3 units in this direction, that's a +3. Well, think about your XY coordinate system. If I have a negative, I just go backwards. I go backwards. So if I go out the 300 line, but I'm going to go backwards, that's going to put me on the 120 line. So I'm going to count out 1, 2, 3, and I'm here at the exact same point. So this ordered pair has 2 different types of points, or 2 different types of ordered pairs. This point has 2 different ordered pairs. It could be 3 and 120, or it could be -3 and 300. Okay, so it can be located by, or has 2 different ordered pairs here. But you just have to, what I sometimes will do is have to put up a straight edge here to make sure I go opposite my 300 to go back to the 120 line and just count out 3 units. Just tells us to go in the opposite direction. So if we go to the back, what we're going to be, our main emphasis here is the graphing. And once again, you'll be able to do the 4 problems on the front of the homework today. You'll do the 4 problems on the front of the homework problems, which is just graphing. Okay, tomorrow we'll worry about the back side here. Let's first set up my graph. I'm still going to count out 1, 2, and 3. 0 degrees, 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210, 240, 270, 300, and 330 degrees. So we still have our angles of rotations going around the circle there. And I'm going every other line for my values. What I want to do is I want to graph this equation. Well, once again, sometimes it's easier to graph in polar coordinates than it is Cartesian coordinates. R equals 1 plus 2 cosine of theta. Okay, what we have to do is we have to go back to our old school ways of how we used to do y equals 2x plus 1. Here's my x, here's my y. I plug in values of x and solve for my values for y. Okay, that's what we had to use. That's what we used to have to do here. Okay, what we have to do here is plug in values of theta and solve for r. Now we won't be able to have a shortcut way of being able to do finding the slope and y-intercept, but we'll be able to plug in values of theta and solve for our values of r. We'll create our ordered pairs, and then we're going to get a graph down. So in the first one, I have 1 plus 2 cosine of 0. So now it becomes a calculator exercise, where I'm taking 1 plus 2 cosine of 0 and hitting enter. And what will come down to is 3 units. And then we're going to put in 1 plus 2 cosine of 30, and we'll get 2.73 units. What I want you to do is go ahead and finish out the rest of the table. Finish out the rest of the table. 1 plus 2 cosine 60, 1 plus 2 cosine 90, 120, 150, 180. Just go ahead and complete the rest of the table. This comes down to 2. This comes down to 1. This comes down to 0. 150, I think it comes down to negative 0.73. 180, I think, comes down to a value of negative 1. 210, 1 plus 2 cosine of 210, negative 0.73. 240, I think that comes down to 0. 1 plus 2 cosine of 270 comes down to a value of 1. 300 comes down to 2. 330 comes down to 2.73. And 360 comes down to 3. Wow. I did that without a calculator. Yeah, I remembered the numbers from this morning. Plus it also follows a pattern. You go in, around, and then back out to value 3. So what we have to do is we have to look to graph this. And once again, if I'm going too fast, go ahead and hit your pause button. If I have the value of 0, r is a value, or theta is a value of 0, I come out 3 units. At 30, on the 30 line, we are at 2.73. Well, this is 2.5, so 2.73 will be close enough, around there. 60, we have a value of 2. So we go out 2 units on 60. 90, we're a value of 1. So on the 90 line, we go out 1 unit. 150, we are at 0. 180, oh, I'm sorry. Skip one. No, 120, we're at 0. I'm sorry. At 120, we're at 0. At 150, we go at negative 0.73. So we have, here is 150, we have to go backwards, negative 0.73. Then 180, we have to go negative 1. Well, positive 1 would take me to here, so I have to go back, negative 1 there. 210, we're back at negative 0.73, so we have to go out the 30 line. Negative 0.73. 240, we're at 0. 270, we come back to 1. So 270, we are at 1. 300, we are at 2. 330 line, we're at 2.73. And 360, we're back up at 3. So there's the plots of my graph. Now the question is, how do we do this? Do I pick up a straight edge and start connecting the dots? Well, how do I connect the dots? Because that's not a straight line. We got them all over the place here. Well, how we graph a polar coordinate graph is we go in graphical or numerical order. We start from 0 to 30 to 60 to 90 and so on. And this is going to be a curve. So it should not be a straight edge from point to point to point. So I'm going to start at 0 and just start curving this around. From 30 to 60 to 90, then we're going to go to 120, which takes me to here. Then we're going to loop around, back to here, and then we're going to finish out the rest of my graph. What this graph is called a lemicon with a loop. It's like a Lucky Charms here. Got some Lucky Charms going. A lemicon with a loop. We'll also have what are called lemicons without the loop. So this one will be a bye-bye. And we also have things called cardioids. We have cardioids. We have 3-leaved rows and 4-leaved rows. And a lot of the graphs in the old school computer games that used to be out there, a lot of the graphics that were done on those were polar coordinate systems. Okay, they are polar graphs. It gives you the curves and the figures, and it made it much easier to be able to graph rather than dealing with an XY coordinate system. Because if we looked at this in the XY coordinate system, okay, which we'll look at tomorrow, what we have here, let's see, this is x over r is equal to 1 plus 2 cosine x over r. I'm sorry. Let me get rid of this. I'm just going to put that r squared. If I multiply through, we get r squared equals r plus 2 cosine. I'm sorry, that shouldn't be cosine of x over r. It should be just cosine of x over r. I multiply through, so I have r squared is equal to r plus 2x. If I simplify this, this comes out to x squared plus y squared is equal to square root of x squared plus y squared plus 2x. So that's the equation in the xy coordinate system for 1 plus 2 cosine theta. Which one's a little bit easier to solve? Well, would you want to put in a value of x here and solve for y? Ouch, that would hurt. That'd hurt. But if I put in a value of theta and solve for r here, that's a little bit easier to deal with. So dealing with polar coordinate systems sometimes is a lot easier, especially when you're dealing with some curvatures. Now what you'll have today in your homework is just, once again, you'll be putting in values of theta and solving for r and getting your ordered pairs. Now, if you get a solution that takes you, it starts you in the middle, takes you to the point, back to the middle, back to the point, back to the middle, back to the point, back to the middle, back to the point, and then just continues to repeat that cycle. That's going to be a 3-leaved or a 4-leaved rows. Okay, and to get your entire graph down here, what you're going to have to do is use some intermediate values. Go every 15 with your values. So you have 0, 15, 30, 45, 60, 75, 90, 105, 120, 135, 155, 165, and then to 180. The nice thing about that is you'll be able to stop at the value of 180. But you'll have to do these intermediate values. What will happen then is you'll get values here, and you'll start getting these 3-leaved or 4-leaved roses. So you'll get some intermediate values. You'll get these intermediate values in here with the 15, 30s, and 45, and so on. So if you get a graph, and the other type is a three-leaved rows, where basically you'll start in the middle, go out, middle here, middle down, middle up, middle out, middle down, and it'll just continue the pattern. You won't get any type of pattern with respect to a graph. Use the intermediate values in there. So hopefully the round two, take two of this, it looked like it turned out a little bit better as I was recording here. You should be able to see it a little bit better this time. Sorry about the initial one. Yeah, I won't wear Shroot Farms anymore. And again, we only have one more day of notes, which is tomorrow. Almost done. Almost done. So hopefully this helps you out. Once again, hopefully it's a little bit clearer graph. One more lesson, one more evaluation will be Wednesday, will be review day, Thursday will be the quiz. And once again, this is for trig and also precalc because we're doing the exact same thing in trig and also precalc. So we're finishing up with the polar coordinates in both the classes. If you have any other questions, feel free to ask. Once again, I'm sorry about the brightness the first time through with respect to my video. Other than that, adios. See ya. See you tomorrow.